Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSim. Today's lab is going to be on configuring layer 2 EtherChannel LACP or link aggregation control protocol. Alright, so let's go ahead and read our objective for this lab. It says EtherChannel can be used to provide high bandwidth redundant links between switches. Under ordinary circumstances, spanning tree protocol would force all but one link between switches into the blocking state, thereby preventing switching loops. However, when EtherChannel is used to combine redundant physical ports into a single logical port, STP considers the EtherChannel port to be a single, non-redundant link. All right, so right here it says Cisco switches can use one of two protocols to enable link aggregation on a EtherChannel: Port Aggregation Protocol, or PAGP, and Link Aggregation Control Protocol, or LACP. LACP is a standards-based protocol that is used to negotiate link aggregation on an EtherChannel. In this lab, you will learn how to create a layer 2 EtherChannel by using LACP. All right, so here's our lab topology that we're working with for this lab. As you can see, we have switch 1 and switch 2, and then we have 4 links connecting these two devices together. Now, of course, as the objective said, normally, if we were just having 4 redundant links to each device, spanning tree protocol would block all 3 of these links and only have one link up. And that is to prevent, like I said, STP or layer 2 loops that would happen if all 4 of these links were up. But we can combine all of these links into a single logical link using EtherChannel technology. And what that does is it allows higher bandwidth, as it explained, and it also allows redundant links between the switches. So if one of these goes down in the EtherChannel, we would have 3 more links basically, okay? All right, so let's take a look at the commands that we're going to be using for this lab. We have configure terminal, which enters a global configuration mode from privilege exec mode. We have channel group number, mode, auto. We have channel group number, desirable. We have channel group number on. We have channel group number, active. And we have channel group number, mode, passive. And this assigns an interface to an EtherChannel group. All right, we have enable, which enters privilege exec mode. We have end, which ends in exit configuration mode. We have interface range, starting port, ending port, which configures a range of interfaces. We have show CDP neighbors, which displays information about directly connected Cisco neighbors. We have show EtherChannel, channel group number, detail. We have show we have show EtherChannel, channel group number, load balance. We have show EtherChannel, EtherChannel number, port. We have show EtherChannel, channel group number, port channel. We have show EtherChannel, channel group number, summary. And lastly, we have show EtherChannel, channel group number, protocol. And this displays EtherChannel information. We have show interfaces type number, which displays interface statistics. We have show running config, which displays the active configuration file. And we have show spanning tree, which displays the spanning tree configuration. Alrighty, so that is the commands that we're going to be using for this lab right here. All right, so let's go ahead and get into our lab task for this lab. We're going to put our topology right here at the top left. We're going to be doing our readings in the top right, and we're going to do our configuration down here at the bottom. All right, so it says right here for task 1, it says review initial configurations. It says in this task, you will review the initial configuration of switch 1 and switch 2. All right, so right here it says on switch 1, issue the command to display CDP neighbor information. Which interfaces are connected. All right, so if we go to switch 1, all right, and I need to refresh because it's an error within Boson. So let's refresh. Let's pull our lab right back up. Let's give it a second for it to load. All right, now we're back. Now we can see as we hit enter, our device host name is popping up. So that's what we wanted. We just seen our VLAN 1 interface come up. All right, and I just want to give it a little bit of time to allow the topology and the network to conform and converge. All right, so let's try it now. Let's do a show CDP neighbor. And we don't have any neighbors yet because CDP is still trying to find out what the topology is. So let's give it a little bit of time. Still nothing yet. This is what happens when you refresh in the middle of making the video. Just give it some time, Still not getting anything. Okay, so we should see the interfaces for switch 2, as we can see from Boson. It says the interfaces from Fast Ethernet 01 through 04 on switch 1 are connected to interfaces from Fast Ethernet 01 through 04 on switch 2. The local interface column indicates the local ports on switch 1, and the port ID column indicates the connected ports on switch 2. So let's try it now. I think the network has converged. Let's try it again. And yes, we are able to see the CDP connections on switch 1. We can see that we have 4 connections to switch 2 using the Fast Ethernet 01, 02, 03, and 04. Oops. The Fast Ethernet 01, 02, 03. If I can highlight 03 and 04. All right. So let me hit the up arrow because I accidentally messed up the output. Yes, so you can see the hold timers. You can see the compatibility. So we can see that we're dealing with switches here. You can see the actual platform of the neighbor device, and you can also see the port ID on the local on the neighboring device. All right. So that is good information to have. So it says on switch 1, issue the command to display spanning tree configuration, which interfaces are forwarding. So on switch 1, let's do a show spanning tree. All right. And you can see that switch 1 is the root bridge. So as we know, if switch 1 is the root bridge, all ports on the root bridge are designated ports. And in that case, all of them are in the forwarding state. All right. So that is what we know about the root bridge. So it says right here for number 3, it says on switch 2, issue the command to display the spanning tree configuration, which interfaces are forwarding. All right. So let's go to switch 2. Let's do an enable. Let's do a show spanning tree. And as you can see, we only have one port that is forwarding, and that is the root port, of course, which is the port that has the best cost to get to the root bridge. And all of the other ports are in the blocking state, and that is to prevent layer 2 loops from occurring within our network, okay? Of course, if our root port goes down, then one of our alternate ports, which would be the Fast Ethernet 02 port, would take over as the root port, because that would be the next port in line because of the priority number to take over as the root port, okay? So number 4, it says, based on the configuration, what limitations does STP as a switching loop prevention technology based on the configuration, what limitations does STP as a switching loop prevention technology place on the network in this scenario? So in this scenario, it is blocking ports that we could be using to prevent loops. But if we use a technology such as EtherChannel, all of these ports will be forwarding, and that would allow us to have higher bandwidth and also redundant links within our network, okay? So let's see what Boson is going to say. It says, because 3 of the 4 ports that connect to switch 2, switch 2 to switch 1 are in the blocking state, the connection between switch 1 and switch 2 is limited to the speed and bandwidth of a single forwarding interface. If switch 1 and switch 2 can combine the 4 connected ports into a single high throughput virtual port, the connection between switch 1 and switch 2 could utilize the speed and bandwidth of all 4 ports simultaneously to transmit and receive data. All right. So let's go ahead and move on to task 2. It says configure layer 2 EtherChannel by using LACP. All right. It says in this task, you will create a layer 2 EtherChannel by using LACP. All right. So it says on switch 1, configure the Fast Ethernet 01 through 04 interfaces to be members of the port channel 1. Use LACP passive mode. What effect does passive mode have on LACP links? All right. So now let's go to switch 1. So let's switch over to switch 1. All right. And let's do a configure terminal. Configure terminal. All right. And let's go into interface range for fast Ethernet 0, 1 through 4. All right. And let's do a channel group 1 mode. And we want you to do a passive mode. So let's put passive and hit enter. And as you can see, we have curated the interface for port channel number 1 right here, as you can see from the output of the CLI. So right here, it says, what effect does passive mode have on a LACP link? Well, passive mode is not going to actively try to negotiate the port channel to come up. Active mode will, though. So passive is more passive. It's going to basically look for another link on the other side that has active mode. Is going to look for the other link on the other side in device to have active mode. And if it receives those initiation packets of LACP, then a port channel will be formed and EtherChannel will be formed. But if both sides are configured as passive mode, a port channel or EtherChannel will not be formed. Okay, so one side of one of the links has to at least be in active mode for the EtherChannel to work. Okay, all right. So right here it says on switch 2, configure the interfaces from fast Ethernet 0, 1 through 4 to be members of port channel 1. Use LACP passive mode. What effect do you expect this configuration to have on switch 2's port channel 1 after you issue the commands? So if we basically it's telling us to configure both sides as passive mode. So because of this, we will not have a port channel formed between the devices because each side of the link is not trying to actively negotiate a port channel. We would have to put one of them in active mode for the port channel to come up. So let's confirm. Let's do a configure terminal. Let's go to interface range, fast Ethernet 0, 1 through 4. And let's do a channel group 1 mode passive. All right. As you can see, we have curated the port channel. All right, so that is curated. So it says on switch 1, issue the command to verify that the port channel exists. In what state is the interface and why? All right, so let's go to switch 1. Let's do an N. And let's do a show EtherChannel summary. Show EtherChannel summary. And as we can see, our port channel 1 has a capital S and a capital D. So what does that mean? The S means that we're operating at layer 2, and we are because we're using switches. And the capital D means down. And that is because we have both sides operating in passive mode. And also, if we look at our ports, we can see that each port has a capital I, which means standalone. So they're operating as standalone ports right now. They're not operating in one logical port as an EtherChannel would. And we can see our protocol is LACP. All right. So now for number 4, it says on switch 1, issue the command to display the EtherChannel summary. In what state is the port channel 1 and why? Well, we just reviewed that. So that is good. Well, we know that our port channel is in the down state, and each of our ports are operating in the standalone state. All right. So number 5, it says on switch 1, issue the commands necessary to configure the interfaces from fast Ethernet 0, 1 through 4 as members of port channel 1. Ensure that switch 1 side of the port channel attempts to negotiate LACP. All right. So yeah, let's go to switch 1. Let's hit configure terminal or type in configure terminal. All right. Let's go interface fast Ethernet 0, 1 through 4. Oops. Okay, I put interface range fast Ethernet 0, 1 through 4. All right, good. Let's do a channel group 1 mode, and instead of passive this time, let's put active. All righty. So now it says, oh, and look at our output now. We can see that the line protocol for port channel 1 is now in the up state. All right, and that is because switch 1 is actively negotiating to have an ether channel with switch 2, and because of that, my port channel has now came up. So now it says on switch 1, on switch 1, issue the command necessary to display the interface configuration, interface information about port channel 1. In what state is the interface now? So if I do a do show IP interface brief, we can see that our port channel 1 interface is now in the up state for status and also in the up state for protocol. So now it says on switch 1, issue the command to display the EtherChannel summary. And what state is the port channel 1 interface now? So now if we do a do show EtherChannel summary, we can see that instead of it being capital SD, we have capital SU. And the U means in use. All right. And we can see that each of our interfaces also have a capital P. And the P means it means that each of these ports are bundled in the port channel, as you can see right here from this output. All right. So now on number 8, it says on switch 2, issue the necessary commands to display the spanning tree information. Which interfaces are forwarding now and why? So now we should only have one interface within the spanning tree output, and that should just be the port channel interface. As you can see right here, we originally have 4. But now if we do a do show spanning tree, yes, we only have the port channel 1 interface as a root port and is in a forwarding state. And that is because all of these 4 interfaces now are bundled within this one logical ether channel or port channel number 1. All right. So now it says on switch 2, issue the command to display the interface information about port channel 1. What bandwidth is used by this interface? So if we do a we do a show interface port channel number 1, we can see that the bandwidth is 400,000. It's 400,000 kilobits per second. All right, and that is because we have 4 100 meg interfaces. So 4 times 100 would be 400. Yes, that is the bandwidth for this interface. So that is the end of this lab. So let's go ahead and hit grade, and hopefully we did everything correctly. And we did. So I appreciate you guys for watching this one, and I'll see you in the next one.